A website is just a machine in a room somewhere, waiting for visitors. On a normal day, a few thousand people knock on its door. It lets them in. It hands them what they asked for, and the whole thing feels effortless. Then one afternoon, with no warning, the knocking turns into a roar. Not thousands of visitors, but millions, all arriving in the same second, all demanding to be served at once. The machine tries to answer every one of them, the way it always does, and that is exactly what kills it. It does not crash because someone broke in. It crashes because it was too polite to say no, and it drowned under the weight of people who were never real. That is a distributed denial of service attack, and once you understand what it actually is, the strange architecture of the modern internet starts to make a lot more sense. What denial of service really means. Start with the plainest version of the idea. Every server has a limit. It has only so much memory, only so many connections it can hold open, only so much road leading up to its front door. A denial of service attack does not try to steal anything or sneak past the lock. It just tries to use up that limit, fill every connection, eat every spare bit of memory, jam the road so completely that real visitors cannot get through. The goal is not to break in. The goal is to make the place useless to everyone else. A shop with its doorway packed wall to wall, with people who will never buy anything, is closed for business just as surely as if the lights were off. And there is more than one way to exhaust the limit, which is worth understanding because the defenses differ. Some attacks aim purely at volume, trying to fill the road itself with so much raw data that nothing else fits. Others are quieter and aim at the machine's attention instead, opening connections and then dawdling, holding each one half finished so the server runs out of slots while barely any traffic moves at all. And some target the most expensive thing a site does, the one page or one search that makes the server work hardest, and ask for it over and over until the back end buckles. They all end in the same place. Real visitors knocking on a door that no longer has the room to answer. Why one attacker is not enough. A single computer trying to do this almost never works anymore. The target is usually bigger than any one machine, with far more capacity than a lone attacker can produce. And the flood coming from one address is trivially easy to recognize and block. You see one house sending you 10 million letters an hour. You stop opening that mailbox. So the word that matters is distributed. The load does not come from one place. It comes from thousands or hundreds of thousands of places at once, scattered across the whole world. And that single change is what turns a nuisance into something that can take down very large targets. The botnet underneath it. Most of those places are not volunteers. They are ordinary devices that have been quietly compromised. A home router with a password nobody ever changed. A cheap security camera running software that was never updated. A laptop that clicked the wrong thing months ago. Each one keeps working normally. The owner never notices. And in the background it waits for instructions. A collection of these compromised machines under one hidden command is called a botnet. On its own, each device is harmless, a trickle of traffic nobody would blink at, but pointed all at once at the same target. That trickle becomes a tide. The people running the network do not need to own a single powerful machine. They borrow the unused scraps of millions of devices that belong to other people, most of whom have no idea they are part of anything at all. Part of what makes this so durable is the sheer number of small connected gadgets that now exist. Every cheap camera, doorbell, thermostat, and router shipped with a weak default password is a candidate. And there are billions of them scattered across homes and offices that will never patch them. When one is compromised, it does not slow down or show symptoms, so nothing prompts the owner to notice or care. That is the grim efficiency of it. The army does not have to be recruited or paid. It is just sitting there, already plugged in, already online, waiting for an address to aim at. The trick of amplifications. Raw numbers are only half the story. Attackers also found a way to make a small push produce an enormous shove. And this is where it gets clever in an uncomfortable way. Scattered across the internet are helpful servers whose whole job is to answer questions. You ask one a short question and it sends back a long answer. That is normal and useful. The abuse comes from a forged return address. An attacker sends one of these servers a tiny request, but writes the victim's address on it instead of their own. The server, doing exactly what it was built to do, sends its big reply not back to the attacker but to the victim. This is called reflection because the traffic bounces off an innocent third party. And when the answer is far larger than the question, it becomes amplification. A small request can summon a reply dozens or even hundreds of times its size. The attacker spends a thimble of traffic and the victim is hit with a bucket. Multiply that across thousands of these reflecting servers, and the modest botnet can throw a flood that looks impossibly large for its actual size. The scale this reaches, it helps to be honest about the numbers because they are hard to picture. The biggest of these floods are now measured in terabits per second. That means the volume of junk arriving each second is larger than the entire normal traffic of some countries. These are not careful, surgical events. They are blunt walls of noise, enough raw data to saturate the fattest pipes on the planet for as long as the flood lasts. For a long time, the defenders were genuinely losing this fight because no single building full of servers could physically swallow that much traffic. The attack was simply bigger than any one place could hold. So the answer, when it came, was not a cleverer lock. It was a completely different shape for the internet itself, spreading one address everywhere. Here is the first piece of the defense, and it is beautifully strange. Normally you think of an address as pointing to one place, the way a street address points to one house. The defense breaks that assumption on purpose. With a technique called anycast, the same address is announced from many locations at once, dozens or hundreds of them spread around the world. When traffic heads for that address, the network naturally delivers it to whichever location is closest. On a normal day, this just makes things faster, since everyone reaches a nearby copy. But during a flood, it does something far more important. The attack does not pile onto one building. It gets split across every location at the same time, each one absorbing only its local slice. A tidal wave aimed at a single door is instead spread along a coastline hundreds of miles long. And suddenly no single point has to survive the whole thing. The scrubbing centers, splitting the traffic is not enough on its own, because a lot of what arrives is still garbage that needs to be thrown out. That job happens in places built specifically for it, often called scrubbing centers. Think of them as enormous filters that the incoming traffic is routed through. Clean, ordinary visitors pass on toward the real server as normal. The obvious junk, the forged floods, and the recognizable attack patterns gets identified and dropped before it ever reaches the target. The hard part is telling the two apart at full speed, because the attacker's whole goal is to make fake traffic look as much like real visitors as possible. So this is never a finished problem. It is a constant sorting at a scale and speed that has to keep up with the flood in real time. The easy cases are the forged floods, the reflection traffic with its telltale shape, and its impossible volume, all of which can be recognized and dropped almost on sight. The harder cases are the attacks that mimic real people. Ordinary-looking requests arriving in ordinary-looking ways, just far too many of them. For those, the system has to study the texture of the traffic, the rhythm of it, the tiny ways a swarm of fakes still behaves differently from a crowd of humans. It is closer to listening for a wrong note in an orchestra than checking a list, and the orchestra is playing at a volume designed to drown out the very thing you are listening for. Rate limiting and patience. There is a quieter layer of defense underneath all of this, and it is mostly about patience. Rate limiting is the simple idea that any single source should only be allowed to ask for so much, so fast. One address trying to hammer the same page 1,000 times a second is not behaving like a person, and the system can slow it down or set it aside without ever having to decide whether it is truly malicious. None of this is dramatic. It is bouncers at 100 doors, each one watching for anyone trying to push through too hard, quietly stepping in front of the ones who do. On its own, it stops very little. Combined with everything else, it sands down a huge amount of the pressure before it ever reaches the part that matters. The giants that soak the floods. Put all of this together, and you arrive at the real reason large sites stay standing. A handful of enormous companies have built networks so vast, with so many locations and so much spare capacity, that they can step in front of almost any target and take the hit on its behalf. These are the big content networks, the same ones that already store copies of the world's most popular sites close to where people live. Their everyday job is speed, keeping a copy of a page near you so it loads fast. But that same sprawling footprint, all those locations and all that bandwidth sitting ready, turns out to be exactly what you need to absorb a flood. When an attack comes, it lands on a network with more capacity than the attacker can ever fill, gets spread thin across the whole world by any cast, scrubbed of its obvious junk, and the small site hiding behind all of it never even feels the wave. Why it is an arms race? It would be nice to say this is solved, but it is not, and it never will be. It is an arms race, and the currency is raw capacity. The attackers grow their botnets by finding the next wave of cheap, forgotten, insecure devices. The next generation of cameras and routers and gadgets shipped with the same weak defaults as always. The defenders grow their networks by building more locations and buying more bandwidth. Each side is simply trying to be bigger than the other on the day it matters. There is no clever final move that ends it, no lock that cannot be picked. Only the question of who can muster more capacity in the moment. The defense holds not because it is smarter, but because, for now, the largest networks on Earth are still larger than the largest floods. The strange piece at the end, and that leaves us somewhere genuinely odd. For years, people have worried, with good reason, about how much of the web now sits behind a tiny number of giant companies. That centralization is real, and it has real costs, and it is fair to be uneasy about so much of the internet depending on so few hands. But the same enormous scale that makes those companies feel a little frightening is also the only thing standing between most websites and the floods that would otherwise wash them away. The size that lets a handful of networks quietly run so much of the web is exactly the size it takes to keep that web on its feet. The giants that centralize the internet are also, strangely, what hold it up. It is not a comfortable peace. But on the day the roar arrives, it is the one that keeps the lights on. If any of this made the machinery a little clearer, subscribe and follow the rabbit hole with us. We take apart one hidden system at a time, the quiet infrastructure most people never see, and explain it from the inside. Next time, we pull apart something almost everyone gets slightly wrong. How VPNs actually work, what they genuinely protect, and the long list of things they quietly do not hide.